Hey guys, today I'm going to show you how to build the Youbionic Robot Hand in Exo Hand. I'm going to show you how to build the firmware for it, build the application, and how to pair it with our system. In this video, we'll be using a really cool 3D printed robot hand in Exo-Glove that was designed by and purchased from Youbionic. This project enables you to build a robot hand that mirrors the movements of the wearable Exo hand. Originally, this project was designed to have the glove and hand hardwired together, but by using the quantum system, we have implemented wireless control. This is an intermediate project, so be ready for more advanced programming and hardware topics. If you need more info, take a look at the description. First, we're going to start with assembling the circuit for the robot hand. So, to do that, you're going to need your PCA 9865, one builder base, 6 male to female jumper wires, and your assembled robot hand with the 6 servos. Okay, so first we'll start by attaching the PCA to the client. We'll start with the ground and power wires first. So to do this, connect one wire to the VCC pin on the PCA, then connect the other end of that wire to the 3.3 volt port on the builder base. Next, we'll connect the ground. To do that, find the pin on the PCA labeled GND, attach a wire to that, and then attach the other end to one of the ground ports on the builder base. Next, we'll do SDA and SCL, as this chip uses I2C communication. Connect 2 wires, or 1 wire to each of those. And then from the pin labeled SCL, attach that wire to the SCL port on the builder base. Then from the pin labeled SDA, attach that wire to the SDA port on the builder base. Lastly, we have the V+ pin on the PCA. We'll attach a wire to that, and then we'll attach the other end of that wire to the 5 volt port on the builder base. Now, we'll go ahead and connect the servos to the PCA. And we're going to start from the pinky, and we're going to move our way down the hand. There's 6 servos attached to this, so we have pinky, ring, middle, index, thumb base, and thumb tip. So take the servo that's connected to the pinky and attach it to the 0 pins on the PCA. You're going to want the orange wire from the servo connected to the PWM line, and then the power and the ground wires will fall into place. Now we'll go with the ring finger. We'll attach that to the 1 pins. Then we'll attach the middle finger to the 2 row of pins. Then we'll go to index, attach that to the 3 row of pins. Then we'll take the thumb base and attach that to the 4 row of pins. And then the thumb tip, and attach that to the number 5 row of pins. So that's it for the robot hand. Simple. We just have the PCA controlled via I2C communication from the builder base, and that controls each one of the servos. So now we'll move on to the Exo hand. You can see here that the potentiometers for each finger lie beneath these pieces of plastic. And because of that, we can't really show you on the Exo hand exactly how the circuit is wired. So we're going to be using some potentiometers and a breadboard to illustrate that. However, we will be using a breadboard to show you the circuit, but with these potentiometers, you should solder the leads onto there. Otherwise, if you were to use jumper wires, you would experience a lot of disconnections and interrupts, so you just don't go down that route. We'll also be using a 5-volt power supply from our DIY kit to be powering this. This allows us to be a little bit more mobile in the use of the Exo Hand. So let's get to it. All right, so here are the 6 potentiometers. Each one of these represents one of the digits: pinky ring, middle, index, thumb base, and thumb tip. And then we have one client, our 5-volt power supply, and 6 male to female jumper wires. You can see here on the potentiometers, we already have the ground and power wires wired up. We did that just in the interest of time. But the pinout for these potentiometers is positive voltage, data line, and ground. And so you can see here that the power, we're using the power rail and the ground rail to power each of these potentiometers. So we'll go ahead and wire the power and the ground for the potentiometers to the builder base now. We'll wire the positive voltage line to the 3.3 volt port on the builder base. And then we'll wire the ground line to one of the ground ports on the builder base. It's very important when using potentiometers with our system that you use 3.3 volts because we use 3.3 volts for our reference voltage. And so if you were to use the 5-volt port, your readings from the potentiometers would be skewed. That's just really important to note. It can cause many headaches if you don't use 3.3 volt port. Okay, so now that we have the power and ground for the potentiometers wired up, we're going to wire the ground and positive voltage ports from our 5-volt power supply kit to the client. So we'll connect the ground line to the ground port, and then we'll connect the positive voltage line to the 5-volt port. All right, now that that's done, we'll wire up the potentiometers to the GP ports. So again, we have the pinky ring, middle, index, thumb base, and thumb tip. We're going to wire from right to left, going down the ports on the builder base sequentially. This mirrors what we did for the servos as well on the robot hand. So we'll wire the pinky potentiometer to the port GP0. The ring potentiometer to GP1. The middle potentiometer to GP2. The index potentiometer to GP3. The thumb base potentiometer to GP4. And lastly, we'll wire the thumb tip potentiometer to GP5. Now, once we flip the switch on the power supply, the LED on the builder base should illuminate. So now you know that at least the power is wired correctly. Okay, so that was just to demonstrate the wiring. We'll be using the actual Exo Hand for the rest of this video. So we're going to want to navigate over to our server, and you're going to want to go to your clients page and just make sure that you actually have the client that you wired the servos to for the robot hand paired to your builder base and the Exo Hand client paired to your builder base. We're going to build the firmware now. You're going to do that by navigating to the firmware builder. You'll go ahead and hit create new, and we'll wire the robot hand or write the firmware for the robot hand first. So this is for the robot hand. Now you'll go to add hardware. You're going to find the servo device, and you're gonna name this servo pinky. And we're just gonna go down the hand, adding servos for each finger. So we'll name this servo ring. We'll name the next one middle, the following one index, the one after that thumb base, and the last one thumb tip. So for each of these servos, we're using the PCA. So you're going to click on the pinky device, and for the driver, you'll select PCA 9685. The I2C address is 40, which is the same I2C address for our PCA. And we're going to set the channel to 0. For ring, you're going to select the PCA again and set this channel to 1. For the middle, you're going to select the PCA and set this channel to 2. For the index, PCA again, set this channel to 3. Thumb base, PCA, channel 4. And the thumb tip, PCA, channel 5. Okay, so that's it for this firmware file. You can go ahead and turn your client on and upload the firmware for this. All right, so now that firmware is uploading, we'll go ahead and work on the firmware for Exo Hand. So I'm going to set the robot hand to the side and bring in the Exo Hand. Here we'll select Create New again. We'll name this firmware file Exo Hand. We'll go to Add Hardware. And now we'll be using a potentiometer for this one. And again, we're going to name each of the potentiometers ring, or pinky, ring, middle, index, thumb base, and thumb tip. So add our pinky, our ring, our middle, our index, our thumb base, and lastly, our thumb tip. Okay, so now for these potentiometers, we used the GPIO ports. We're just using the GP ports. And we wired these sequentially as well. So for this pin, we're selecting GP0. For the pinky, for the ring, we're selecting GP1. For the middle, we select GP2. For the index, we select GP3. For the thumb base, GP4. And lastly, the thumb tip, GP5. All right, now that firmware is done, go ahead and save it. We're going to upload this one to our client that's attached to the Exo Hand. All right, now that the firmware upload is complete for the Exo Hand, we can go ahead and figure out the ranges for each potentiometer. We use 10K potentiometers, but because of the way in which the Youbionic hand articulates, we only get a small subset of that range. So we need to figure out that range so that we can use that range in our application to determine when the finger has been extended and when it's retracted. So to do that, we're going to go from the firmware page to our client's page. We're going to navigate to the Exo Hand, and we're going to go to the debug menu. You're going to want to grab a piece of paper and a pen to write these down. So you have these values handy when you're writing your application. So for the pinky, we're going to put on the glove, and we'll hold it in the retracted state. And then we'll hit read. And so for the pinky, we have a successful read of 3200. Now we're going to do the same thing for its extension. So we'll extend the pinky up. And now we have a reading of 4057. So now we'll do the same thing for the ring. So we're going to read it. It's retracted. We got a reading of 3172. Now we'll extend it. We have a reading of 4056. Okay, so now we'll go to the middle finger. We'll go ahead and retract it. We have a reading of 3612. Now we'll take the reading from when the middle finger is extended. Reading of 4057. I'll do the index. Read it when it's retracted, 3374, and extended. Four 057. Now for the thumb base, we'll extend it. Extension is 3684. And with it retracted, 4056. The thumb tip, we'll read it retracted, 3469, and extended, 4058. All right. So now we're going to build the application so that we can utilize the Exo Hand and the robot hand in conjunction with one another. You're going to want to have these values that we just took handy. So we're going to go to your applications page and you're going to hit the create new button. We're going to call this application robot plus Exo. I like the sound of that more. Okay, so once you're at your app builder, you're at the canvas, you're going to search for the potentiometer hardware object. You're going to drag 6 of these onto the screen, one to represent each potentiometer on the Exo Hand. Okay, almost there. All right, we have 6 of them. Okay, now that those are on the screen, we can add 6 manual ranging code objects. This is where we will input the numbers that we just took from the potentiometer ranges, and this will allow us to determine when the hand is, when a single digit is open and closed. It will give us the proper range for that. Okay, so there's 6 of those. Let's make them pretty, because no one likes something ugly. All right, so now we'll drag 6 servo objects onto the screen. This is a lot of fun, as you can tell. No, it is. I'm just playing. All right, so that's number 5. Here we go. It's number 6. Okay, so when you're building a larger application, it's always good practice to save your app incrementally, because if you don't, you have no idea what could happen. You could put hours of work into an application and then in an instant it could be gone due to power outages or whatever. Always best practice. Honestly, just good practice in life, I'd say. Okay, so now that we have these arranged, you're going to want to drag the value out nodes to the value in node on the manual ranging object, and then the value out node to the value to the degree node on the servo. So you're going to repeat this for each one of these object pairings. Yep, just go on down the list. Connect value to value and value to degrees. Just going to pretty it up a little bit. Whoa there. Okay. So it's always best practice to name your objects. This just allows you to keep everything organized, in particular, once you're mapping your application. So You can see here we named each potentiometer, pinky ring, middle, index, thumb base, thumb tip. We're going down the line. And we name the manual ranging object to follow that naming convention as well, and the servos to follow that. So now we can input the values that we took from the debug menu into our manual ranging objects to give us the proper range of the potentiometers. So for the in minimum for the pinky manual ranging object, input minimum from the retracted state is 3200. Now the input maximum from the extended state is 4057. Out minimum we'll keep to 0, and the out maximum we're going to set to 180. That represents 0 to 180 degree range for the servo. Stuttered there. All right, so the input minimum for the ring is 3172. The input maximum is 4056. Now the output minimum again is 0, and the output maximum is again 180. Input minimum for the middle finger is 3612. The input maximum is 4057. Remember, these values are for our potentiometers in the way in which we constructed our Exo Hand. Your values will likely be very similar, but there is a chance that there will be some variation. So I don't suggest you just follow the numbers we give you. You should go to the debug menu and gather the numbers yourself. So the output minimum for the middle finger is again 0, and the output maximum is 180. The input minimum for the index finger is 3074. And the input maximum is 4057. The out minimum again is 0, and the out maximum is 180. The thumb base, our input minimum is 3684. Input maximum is 4056. Now, this is where the thumb base manual ranging changes. The servo, the way in which it's positioned on the robot hand, needs to rotate in the opposite direction as compared to all the other servos on the robot hand. And so to do this, instead of setting the output min to 0, we set it to 180. And then the output maximum, we leave at 0. This will invert our range. So now the thumb tip is just like the other previous potentiometers, and the input minimum is 3409, and the input maximum is 4058. And the output minimum and output maximums follows the same schema as the other ones. The output minimum is 0, and the output maximum is 180. So now we can go ahead and save this application. It is complete. We can go and see how well our robot hand works. Beautiful. Okay, so now have your Exo Hand handy and your robot hand handy as well. You're going to want to make sure both clients are powered. And now we're going to walk through how to properly map this application to the clients. Okay, so with both clients turned on, we're going to map the potentiometers, the ring potentiometer to the ring potentiometer. The ring potentiometer in the application is mapped to the ring potentiometer on our client, listed in our firmware file. So we're going to go Exo Hand ring, Exo Hand index, Exo Hand middle, Exo Hand thumb base, Exo Hand thumb tip, and then we'll just get the pinky potentiometer out of the way as well, Exo Hand pinky. So now we're going to map the servos in our application to the servos on our robot hand. So you'll notice that when you go to map these servos, The name of the client changes. So before, for the potentiometers, it was Exo Hand, which has all the potentiometers on it. And now it's Robot Hands. This guy has all the servos. So Robot Hands pinky. For the ring, we select Robot Hand ring. For the index, we select Robot Hand index. Thumb base, thumb tip, and the Robot Hand middle. Okay. So now that our application is mapped, let's see if it works as we expect it to. Okay, our application's built, clients are paired, mapping's occurred. We're ready to see exactly what it is that we built. Our middle finger is a little errant here. I think one of the potentiometers in our glove was somehow messed up during the build process. We're just gonna disregard that for now because the rest of the digits work. Okay, but you can see I'm moving the thumb. The thumb on the robot hand moves, as well as the index finger. I can make a fist, or a partial fist, thanks, middle finger. Oop, accidental middle finger to the camera, beautiful. Yeah, that's what we've created. As you can see here, we were able to get the Exo Hand to work. We figured out that it was an issue with the middle finger potentiometer. This had nothing to do with the quantum system. We hope you enjoyed this video. Check out the rest of our videos. Remember to subscribe to our YouTube channel and click the notification button for updates. You can also follow us on social media. Thanks for watching.